Assalamualaikum warahmatullahi wabarakatuh. Uh, Actually, I want to share with you about Proskit SS-331 Desoldering Station. I just fixed it up because you got some problem. So now it is okay. So during fixing it up, I was studying about the system inside this soldering station. So I think this might be help you if you got the same problem with me in the future. If you got a problem, then you can refer to this video. At least this video can help you, because I see not many video about this soldering station. Okay, this soldering station actually an old model model. This is blue in color. Okay, the new one is green in color. So I think this model is already obsolete. New model come out with green in color, and then the system is a bit different, but more or less they are the same. So I think if you got problem, please watching this video. Before that, please subscribe and like the video. Okay, the problem of this soldering session is the gun is not hot. The gun is got temperature problem. I mean, it no temperature at all. No, I mean, no heating. The heating element is not function. Okay, so when I change this gun to other set, the gun was function well. It's function well. So that means the gun is okay, but the system, internal system of this set got problem. So I have fixed it up. This actually the problem come from this display, our control board. Okay, this control board actually control everything through this microcontroller here. This is if you can see the number, wait, I try to see the numbers very small. OB39A32, something like that. This is on bright. The Taiwanese semiconductor industry produce the IC, because actually Proskit is from Taiwan, so they use semiconductor from Taiwanese industry. So this control board will control everything. This is switching mode power supply. This is gun. As I said before, the gun been connected to the system through this cable through here, and then we have suction air from here to suck the pad or to desoldering the pad. Okay, I mean to desoldering the solder that you want to take it out. So the air or the vacuum is come from this connected to here, this side, and then this motor will suck the unwanted desoldering, the unwanted solder from the pad. So as I said before, this microcontroller control everything. It control the PWM. I mean, it produce PWM. Okay, the PWM will go to this connector. After I will show to you. And then this is power from switching mode power supply to this board. The power is around 10 volts, something like that. Then this is regulator here in SMD component 7805, if not mistaken. It will regulate the voltage to 5 volt, and I believe the board is using 5 volt taken from here and then regulated by this regulator. And then this connector is button control. The button control here being connected through this connector to the microcontroller, and this is a temperature sensor from the gun. Will feed it here. Also will go to microcontroller through this op-amps 386, if not mistaken. The microcontroller get help from EEPROM here. Okay, all the data they put in EEPROM. So the microcontroller, of course, have source code or program inside. And then this hot tag for display. Okay, so that means everything is controlled through here. I believe this preset is to setting maybe temperature or what, I don't know. I think the sensor inside the gun is thermocouple, I believe. Thermocouple and being fit through here, through this op-amps, and then go straight away to the microcontroller to have a feedback, to get the feedback from the actual temperature of the heater or heater element. So as I said, okay, this is the connector behind. Okay, this is PWM, green and yellow cable or wire. PWM, this is supply for the board. This is for control purpose. All the control button will connect to here for the microcontroller to know whether you want to increase or decrease the setting of the temperature. And then this is the thermocouple or temperature sensor from gun, also to for microcontroller to monitor the temperature inside the gun. So this is switching mode power supply, 18 volt, 12 amp, I believe. So everything control by this control panel. Okay, the switching mode power supply we have a MOSFET inside as well as autocoupler. They will receive PWM, pulse wave modulation, from control board. So the MOSFET will send the PWM into the gun. So the heater element, we got two wires. First wire is 18 volt, second wire is PWM, so that the heating element will heat up through PWM and 18 volt DC. Okay, so let us try to switch it on. Before that, okay, here is the inside the power supply, switching mode power supply. You can see this cable, green and yellow cable for PWM. Okay, go the PWM will fit. I mean the PWM is fitting, is is sent to the autocoupler, and then the autocoupler receive it and send the PWM signal into the MOSFET, and then the PWM will come out through this white wire. Well, the white wire is connected to this terminal and straight away go to the heating element inside the soldering gun. So this is normal normal switching mode, but there is a bit additional circuit to receive the PWM, and then PWM as well as 18 volt DC supply will feed up to the heating coil in the gun. Okay, so let us try to switch on the desoldering station. Okay, if you notice here, up to increase, down to decrease the temperature. This is to change the temperature unit, whether Celsius or Fahrenheit. Okay, so please focus to the PWM signal which I'm taken from this cable. Okay, white cable. This PWM will heating up the heating element inside the gun. Okay, I'll try to on. Bismillah. Okay, I'm setting the temperature at 880 degrees Celsius. You can see the temperature, I mean the PWM. You can see the signal, PWM signal. It is about 355 Hertz, 18 volt, 345 Hertz, 18 volt. This is the signal actually been feed up to the heating element to heat it up. Okay, so I set the temperature at 380 degrees Celsius. So now the heater, now it is 380 degrees Celsius. This is setting temperature. This is the actual temperature inside the gun. Okay, you can see the PWM is on and off. I'll try to make it a bit bigger. The PWM will on and off because of what? They will give the PWM and off it according to the temperature, to make the temperature constant to 380 degrees Celsius, which has been setting in this system. So they will make it on and off, so that the temperature is stay there. It's not decrease or increase, more or less in that around 380. So they will inject the PWM, and then they stop for a while, then inject it again, so that the heating element is according to the temperature that we have set. So you can decrease the temperature. You can decrease the, let's say I decrease the temperature down to, let's say, 250. Okay, Okay, 250. So the at this condition, when you decrease the temperature, the system will stop injecting PWM inside the gun, so that the heating element will cool down a bit to the temperature that we have new set. We have set it lately. That is 250. So the temperature, the PWM will shut off for a while, will dash for a while until it reach the setting temperature. Then only will inject back. You see, the PWM now is being inject again to the gun, so that the gun will constantly at the temperature as we set, 250 degrees Celsius. Actually, before I'm repair this set, I thought the gun element inside the gun is using AC signal, AC voltage. But when I make a try to observe, actually it's using PWM, not AC signal. And then before this, I thought the temperature is been controlling through period. That's mean the PWM will will control the period, so that it will control the temperature. You see, higher value of temperature will have shorter period. That's mean very fast. I thought before they are using that system. If lower, then the period will the frequency will a bit slower. I mean the PWM, the frequency of PWM a bit lower according to the setting. But no, actually they are using a constant PWM signal. That's mean 345 Hz. But they are controlling the time, the injection time to the gun. You see, the injection time to the gun. So if we set it in high degree Celsius, that's mean the frequent injection time will will increase. You see, they will increase the time, injection time to the gun, so that the heater will heating up constantly at that high level temperature. If we set it down, I mean decrease the temperature, so the time of injection time also will decrease, so that the temperature will lower as we are setting it in low temperature. So they are controlling the time, injection time to the gun. You see, again I will increase. You can see I will increase the temperature, increase up the temperature. When I increase up the temperature, they will constantly inject the PWM, so that the temperature will faster go to the higher level as I said. You can see now I try to go back to 380. You see the temperature, the PWM will constantly be injected, not as before that when you decrease, the PWM will dash, so that the heating element will go down, the temperature of heating element will go down. But when you setting it up, the temperature is higher than what we have set here, then they will constantly inject the PWM, so that the heating element fastly go to that new setting level. That's mean higher from this. Okay, let's say we inject it to 380. You see the temperature is constantly being injected. 345 volt, 18 volt, 345 hertz, 18 volt. Okay, and then they will start again the injection process, dash and on, off and on, so that to control the heating element, the temperature of heating element inside the gun. This is how this system works. It's so easy to understand, very easy to understand. So I think I hope this video will benefit to you. So if you have any comment or you want to ask any question, then please you can put in the comment below. Thank you for watching. See you around. Bye.